Hello, everyone. Hope you all had a good weekend. Has anybody ever just come to this room and just kind of like, okay, I'm rested and recharged from the weekend and I am ready for AIS. I'm absolutely ready, set, and prepared. Or is everybody just kind of like, I wish the weekend was longer? That's kind of how I am in the morning. When I wake up, I was just kind of like, I just really want to sleep for a little while longer. I forced myself to get out of bed. Is anybody here not a morning person? Like, I got a lot of people who are morning people, which that makes me both envious and sad at the same time. Yeah, I really wish I could be a morning person. Oh, okay. So I got some notifications that a lot of people attended Meet the Firms. Hope that turned out well for everybody and had some good experiences there. I talked to a lot of the representatives from Meet the Firms, and they were very, very gung ho about all the people that they talked to. So good work on that. Again, as a reminder, if you did not attend Meet the Firms, or if you did attend Meet the Firms and just want another exposure, there's an item coming up in a couple weeks. It's going to be a career expo. It is not constrained to just accounting firms or business or companies. So there's going to be a lot of opportunities there. So I encourage you to take a part of that if you are looking for an opportunity. Again, that's the other extra credit opportunity if you did not attend Meet the Firms. Just as a reminder, if you attend Meet the Firms, I will be getting a printout for that. It's not always 100% accurate, but it's pretty close. I will remind you to check your grade to make sure that I got you posted for Meet the Firms. If you did not attend Meet the Firms and are attending the Career Expo, you will need to tell me that you attended the Career Expo because I do not get a printout for that. They don't have a sign up for that. So you'll just need to inform me that you attended. All right. Today, we're going to be talking about relational databases and enterprise systems. This is going to be what I would say for this chapter in the scope of the chapters that we're going to be covering for the first exam, which again is going to be 7 chapters. This is a minor one in context. It is one that, first of all, I think is fairly intuitive and just kind of is an expansion of some of the concepts we've talked about. Plus, I think it's one that a lot of people will already be familiar with, simply because a lot of people do have experience with other tech courses, particularly Access, and may be able to work in those programs. We're not going to be learning anything too profound here. We're just going to be clarifying a lot of the things that we've already talked about. That being said, I cannot emphasize enough how much relational databases have changed the face of our business and the way people operate in today's society. It's one of those things that it seems so subtle and distinct right now, but it was such a profound change from the way things operated, even just 30 years ago. So let's go ahead and we're going to talk a little bit about the history of relational databases, and then we're going to get into the nitty-gritty of how this relates to what we've already talked about. So if you recall from chapter 4 that systems become increasingly complex over time. Remember I did give you the diagram and I say, this is an iPad, this is an IBM PC 5150, this is a Columbia punch card computer. And that was going back in time. So the logical intuition is that they become better over time. So early computerized accounting systems, they were relatively simple. They used conventional processing, which mimicked paper-based systems. Now, this is an important point because this kind of explains why a lot of your business courses that you may have taken and why probably all the business courses that occurred in the 1990s and 2000s were all very, very paper distinguished. Like I'm sure that this is one of those things that we talk a little bit about the transition from going from a paper-based system to a computerized system. Even just looking at NetSuite for the first time, you probably realized this does not look a lot like what I learned back in 220 and 221. And that's correct. All right. There's been a big transition in the way that things operate from paper-based systems to computerized systems. But if you go back to the 1970s and 1980s when computers were first at their forefront, basically all the computer was doing is taking a piece of paper for accounting and putting that piece of paper into a computer. There was no real transfer of there's no real adaptation. There was no real transfer of information to make it more versatile. It was just taking the paper and putting it on a computer form, which sounds like it'd be more convenient, but it creates some problems. And we're going to talk about the details of those. Now, while the simplicity of conventional processing was appealing, simplicity was basically that anybody could build a machine and it could be any company could have one. It did limit the overall depth of the AIS. Now, I know everybody is really well rested from the weekend, and so your question is, how did it limit the depth of the AIS, Dr. Barnes? I really want a lot of details that go into this, and I'm going to say I'm so glad you asked because I prepared an entire slide to talk about how it limited the depth. So here's some disadvantages of conventional processing. Now, again, just to clarify, conventional processing is the way computers originally started out, the ways that computers were back in the 60s, 70s, and 80s. I probably should say more 70s and 80s, though we did have computers back in the 60s that actually held databases, which we're going to talk a little bit about. All right, so first, system and simplicity. Basically, the systems themselves were very, very archaic and very, very old and outdated, and they could not handle a lot of detail, a lot of data. Remember, I was talking about when I had the IBM PC 5150. This was a couple weeks ago, and I was saying my dad bought the computer and he's got it upgraded to the hard drive, and the hard drive was 40 megabytes. Yeah, that was kind of the parameters we were operating with back then. It was not a lot of space for processing. The RAM was even more limited. So a lot of the work that we did was going to be limited in scope, and because not a lot of flexibility in the way that we approached the particular problem. That kind of leads to the next problem, is the inflexibility of data structures. Okay, so this one seems less intuitive, but basically what this means is that the form that you put into the computer is the form that you had to operate with. Think about a piece of paper. If you created a table in written form, so you have an Excel spreadsheet and you write that down. Okay, you write that down on a piece of paper, and then I say, all right, I want you to move columns. Can you actually move the column on the piece of paper? Can you actually copy and paste something on a piece of paper and move it? I guess you could take scissors and then you could copy it and paste it onto another piece of paper. I guess technically yes, but it would be a very, very challenging process to do. All right, without butchering everything that's already up, it's not a flexible thing. And that's kind of how old systems operated. Is that you couldn't move data around, it couldn't transfer information between one point and another. It was just basically what was set up, was the way it came up. You could add new information, but you could not really edit the information or change the format. This is a big one. This is the inability to query data. All right. So I like to use this term a lot. Has everybody in the room heard the term query before? Or does everybody know what the term means? If you don't know what the term means, it's a pretty basic term. This is not something I'm going to test on, but I think it's very important for you to know. When you hear the term query, all that means is you are asking a question of the data. And old conventional processing systems were not very good about being able to ask questions. Now, some of them were designed to answer certain questions, like, okay, what are the names of our vendors? All right, so you can actually go through, you can see the vendor names in a vendor table. That was something that was set up by design. You could ask that, and you could actually ask the table to give you that. But say, for example, you say, I want to see the last 5 transactions from this vendor. That is not something you could do in a conventional processing system. It's not something you could actually set up and do. And so that was a big problem, because as our needs change, as the environment changes, then so do the types of questions that we're going to ask of data. So being unable to query data in any meaningful way was certainly a problem. Then we have data redundancy. All right, so data redundancy is a big one also. So in conventional processing system, the table was the table. It did not have draw across data from across other tables. So easy example of this. Let's say that I want to do business with a company. All right, I want to do business with a company. So I say, I would like to do business with you. They're going to put my name into a customer database. And what would my name be? Everybody says Dr. Barnes. So yeah, well, I appreciate that, but my name is Michael Barnes. Okay, so they put Michael Barnes in the customer database. Then they ship me out some goods, so they've got a shipping database, so shipping transaction file. They put Michael Barnes as the name there too, and then they have a cash receipts, because I'm going to pay, because I'm a good customer. I'm going to pay, so cash receipts file, Michael Barnes. Now, all 3 of those scenarios, I had the exact same name, Michael Barnes. All right, that would be the best case scenario. But what happens if I, in the customer database, say, "What's your name?" It says, "I am Michael V. Barnes Jr., PhD, CPA." Other initials too. Yeah. So I start throwing all this stuff out. So they put Michael V. Barnes Jr., PhD, CPA. All right. Then when I go to the shipping, I say, all right, I'm Michael V. Barnes. All right. So they put in Michael V. Barnes shipping, and then said cash receipts. I'm just like, I'm done with all the hoopla. I'm Michael Barnes. Actually, I'm going to say I'm Mike Barnes. There we go. I'm Mike Barnes. Are those the same thing? And you're going to say, yeah, those are the same thing, Dr. Barnes. They all mean the same thing. I said, I didn't say that they mean the same thing. Are those the exact same inputs? No. And that's the problem, is that not only was the data redundant, that we had to store it 3 different times, but there's inconsistency in the importing. So yeah, that's going to kind of lead to the other items that we have here, is the poor data quality and inconsistency of the data formatting. Is that you can have the exact same field across multiple tables and have different inputs for the same item. Okay, for the same record, Michael Barnes, You could have Michael V. Barnes Jr., PhD, CPA. You could have Michael V. Barnes. You could have Mike Barnes. You could have Michael Barnes. Whole bunch of different iterations, which is chaos when you're trying to match records across files. Just absolute chaos. So inconsistency of data formatting, and keep in mind that if you're in a large organization, the people who are handling the customer approval and transactions are different from the customer or for people who are handling shipments to the customers, and those are different from the people who are handling the cash receipts. So they're not necessarily incentivized to enter the information consistently with everybody else. It creates a lot of problems. Now we're going to see why that was why the relational databases fix those problems in a second. But trust me when I say, when you have the inflexible data structures and the poor data quality across that, matching information can be really problematic. Also, it's just an inefficient use of resources. Now, think about this logically. If you're doing an assignment that was multiple pages, all right? Well, if you're talking to your instructor and you say, okay, is it okay if I just put my name on the front page of the paper, and they say yes, that's fine, you probably be pretty thrilled about that because you just have to put your name down one time. Now, what if your instructor says, well, it's a 20-page paper, I would like your name on every single page of paper? How are you going to feel about that? I mean, a few people might just be like, it is what it is, but everybody's going to like, this is a massive waste of time. I have to write my name on every page of paper. And, you know, and even though it's probably only like 2 or 3 minutes, that's 2 or 3 minutes of your life you're not getting back, okay? Much like this class. So yeah, you're just going to basically be a complete waste of time. And time is one of your resources. You're going to say, what is the point of that? That is effectively what people were doing back with conventional processing systems. We had to record our name in the customer database. We had to record our name in a shipping database, record our name in the cash database. All three of those contained a field for that. What was the point of that? The point was because we could not transfer information across databases, we had to record it multiple times. Now, given that we have a premium on storage space, that's really problematic. It means that there's going to be a lot of issues created as a result of that. So what is the solution for this? And the answer is that going to be the modern database system, okay? Now, I refer to this as conventional processing. I use the term database. There's not traditional databases in the senses. It's a place where data was stored. So in a logical sense, it's a database item, but these are not traditional databases as we think of them. The term database didn't come around to usage until the late 1980s. So what do we mean by databases, okay? Database systems operate logically similar to conventional processing systems, but avoid the physical structure issues, which basically means that we can replicate everything that the old conventional processing systems did, but we can do a lot more with it because we actually don't store it in the same way. So we already have a template for how conventional processing systems are stored. Every single department had their own series of records or places that they stored information, and those were basically inflexible. They could not be changed. And that was proprietary for usage. In a database system, we still have individual areas where information is stored, but we try to minimize the storage across the tables that we actually use. So saying that the customer database, and we identify certain pieces of information that are related to that customer. So the customer's name, the customer's customer ID, their address, their credit limit, things like that. And then we can match that across other database tables. All right, we can match that across other databases within the system. So when we talk about the customer places an order, then we're going to be able to match that customer ID according to when they placed an order, and we'll actually gather requisite information across tables. So the way that a database is structured is that all the information is stored within the database according table, according to what area you're operating with. Then you've got this thing called the database management system. And all the database management system is a fancy term for a querying tool. It basically, you put the query into the database management system, and it'll say, here are the pieces of information I need to facilitate this query. I'm going to find that, pull that for you, and then provide the result. And then the result will be delivered to the app or user that's using that. Now, user would be the direct individuals who are actually making those queries. An app would be more of a process, an application that runs a query on a periodic basis. So say, for example, you have an exception report that runs every single day. All the exception report says is that I want to find all transactions that did not meet the parameters of a particular value. The database management system will run that query for you, and it happens on an automatic basis, a continuous basis. So that's why apps can actually be querying tools or querying mechanisms as well as users. So database systems, there's basically a collection of related data for various uses, and there's 3 types of models. Now, the first two are largely irrelevant, and I'm not going to ask you too much about that. I would be familiar with their names, but for the most part, they're antiquated and they don't get used very much anymore. Hierarchical is just as it sounds, is basically establishes a hierarchy for usage of information and establishes what is going to be the primary pieces of information, and then everything below that is going to be kind of subsequent to that. Whereas a network data model is more about asking for detail across the network about what's relevant to that particular item within the network that it's operating in. What we're concerned about is going to be the third one I've already alluded to, because we talked about relational databases as the title of this chapter. We're concerned about relational data models. And a relational data model is one that stores information in the form of related two-dimensional tables. Now, this is why I said that if you've ever done Access class before, or familiar with the use of Access, you're going to seem very, very much at home at this. But we're already got some familiarity with two-dimensional tables with the work we've done in Excel. Now, I'm not going to say that Excel is a relational database. It's going to be what we're going to replicate because it's a lot simpler to understand in this course. But for the most part, what we're going to be looking at with mechanisms as Excel are going to be reminiscent of how the relational databases operate. So let's go ahead and get into a little bit of detail about why relational databases fix some of the problems with the conventional processing systems we talked about before. So relational data models allow designers and users to identify relationships when the database is created, or much later whenever new requirements for data model are desired. Now let's talk about each of those because both of these are very relevant. Remember before I said we've got one user and that user got stored in 3 different spots before. If I create a common user, a common user ID item, okay, so it's going to be our primary key that we're talking about within the customer table, then I can use that in other tables to match when necessary. So example is, I'm Michael Barnes. My customer ID is 12345. I can put that in the customer table as my primary key, and then I can use that as an identifier for subsequent tables that are going to need that information. For example, the customer who performed this sales transaction, who was responsible for the sales transaction, was customer 12345. The customer who just made the cash receipt or cash payments that we just received was customer 12345. All of this can be drawn across the entire system, and it serves a couple of advantages. First of all, using that one identifier, that 12345, I only have to record certain information one time. Okay, I can record the customer name, Michael Barnes. It's going to be used in that format, exactly that format, along with all the relevant customer information with that. Then when I draw that from the sales table, I can actually pull that information across as necessary. So they may want to say, all right, I've got a sales transaction to customer 12345. This customer's name is Michael Barnes. This customer is located in Kirksville, Missouri. Where did I get that? I got that from the customer table. It allows information across different databases to be pulled, or not databases, data tables to be pulled and used as necessary. The key being is that we actually identify the relationships. We actually can identify relationships between the tables. We got the customer table and the sales table, and we can combine those two through a common key, which was that 12345, that customer ID key that we talked about before. So we've already alluded to primary keys and foreign keys, but this will become a lot more of an important concept moving forward. Probably more critical is that we can actually identify relationships even later when new parameters are desired. So if we have to actually add information, if we want to add detail to our database, we can create new relationships whenever we think it's relevant. Now, why is this important? It's because technology and the environment in which we operate in is constantly changing. How many people think that most organizations had some sort of crypto database 20 years ago? 20 years ago, crypto didn't exist, by the way. Crypto's origins were actually in 2008. Okay, so crypto assets are less than 20 years old. So obviously, nobody had any kind of crypto database there. Now, large organizations have cryptocurrency databases and different types of crypto they will accept for transaction exchanges. So they can create a new database and identify data tables and identify transactions within the database. They can actually create new relationships depending on the necessity of those. That's a pretty easy example, considering that that's one that did not exist for many database systems or any database systems way back then. So advantages of relational data models. They're flexible and scalable. They handle changes quickly and easily. So the examples of these kind of database systems that are commonly used, SAP, Oracle, and Microsoft are some of the big ones. We have some familiarity with one of those already, Oracle, because we're operating in NetSuite, which is basically a scaled down version of Oracle, but still a really powerful one. They're simple. It's easy to communicate to both users and developers. Okay, so whenever something needs to be changed within the system, the users can communicate to the developers, and the developers can fix or adjust the problems or adjust to the problems as necessary. And probably one of the most important issues is there's a reduced information redundancy. Most data has to be only recorded in once. Now, I want to make a quick note about this. The word most is critical here. I didn't say all data. I said most data has to only be recorded in once. Some of the data will have to be recorded multiple times because we have to create relations between the tables. And if those relations don't exist, we can't use data across tables. But for the most part, we avoid a lot of the redundancy before. Remember that customer table I talked about before? I said, okay, Michael Barnes is the name, my address, city, state, so on and so forth. That would be information that's in the customer table. In the conventional processing system, that probably was also contained within the sales table and the cash receipts table. So a lot of information redundancy there. In a relational database, I only have to record my name. Well, they only have to record my name, my address, and my city and zip code. They only have to record that one time in the customer table. If they need that information for some other use, they can pull it from the customer table because of the relationship existence. So that's one of the most important things, is that it helps the use of resources. We can actually utilize those resources for other purposes, such as more transactions and more reporting analysis, basically adding value to the information that we already have. Now, some of the terms that we're going to talk about here, I'm going to go through this pretty quickly. We've already alluded to most of these terms. So data dictionary describes the data fields in each database records, a field description, field length, field type, etc. This is kind of important because we have to know what is the purpose of a particular field and what are its default values and what can we input in a particular area. This is kind of one that's a no-brainer. You have to have something like this. Otherwise, you're not going to be able to input information correctly within the system. Database administrator is one that we're already familiar with. This is responsible for the design, implementation, repair, and security of a firm's database. Why are we familiar with this? Because we're all administrators in NetSuite right now. Now, again, you're going to hear me say this many, many times in this course, and you're going to get sick of it. You're going to say, yes, I remember, Dr. Barnes, you said this like 1,000 times before, and I'm not going to be satisfied until I say it like 2,000 times. But the simple truth is that as an administrator, we should not be responsible for recording transactions. Our responsibilities as administrator would technically be for maintenance and security of a system. The reason that we take that role for our NetSuite work that we're going to be doing in this course is because an administrator has access to all parts of the system, which is not true for most other users. So technically speaking, as an administrator, we should just be maintaining and ensuring security in the system. We're going to be doing a lot more than that just because we have access abilities in that. Then we have the database management system. It's to manage data in response to program users. Again, this was our querying tool that we talked about before, that we ask a question of the database and it provides the feedback that we actually are looking for in a particular scenario. All right, let's go ahead and link this to some things that we've already talked about. Let's talk about entities and attributes, okay? So entities are items that are classes in the relational database about which the information is stored. We had 3 entities that we talked about last week. Does everybody remember those? Right on top of it? Yeah, REA, resources, events, or agents, okay? So these are classes that are grouped in resource, events, and agents. Now note here, classes in this terminology is exclusive to entity, okay? We do have a 4th class. Does everybody remember what that 4th class is called? Conceptual structures. I knew you knew. I knew you knew it. The roar was deafening coming from my end. Okay, I'm surprised it didn't knock me backward a little bit. Yeah, conceptual structures. Now, the kind of classes they're talking about here are just the entities. Okay, we have the events, business activity, resource, an asset involved in the event. Okay, an agent, an individual involved in the event. We're going to be revisiting all of those as well as conceptual structures many, many times before the next exam, so don't worry too much about that. We also need to know attributes, which are characteristics, properties, or adjectives that describe the entities. Now, how does this relate? Well, we already know about entities, resources, cash and products, events, sales and purchases, agents, customers, and salespeople. For our purposes, to be honest, we're not going to go too much beyond what we see right up here in this table. We may look at some visual examples that expand upon this, but from true business perspective, these are going to be pretty much our resource, events, and agents in most of our transactions. All right. Now, characteristics are going to be things that describe, or characteristics describe the whatever the entity that we're looking at. So a good example would be the customer ID or the address. Properties would basically be something that are a unique identifier of whatever the particular table we're looking at or the particular relation we're looking at. So invoice number or date. And then I use this term because the book uses this term, but it's a little bit of a misnomer because it says adjectives, but you will notice that product name is not an adjective from the grammatical sense. That is a noun, okay? So if you are a former English major and you're just really, really mad about me calling product name an adjective, I get that, okay? And I feel for you. But the adjectives in this terminology are just basically descriptors, okay? Descriptors of whatever it is that we're looking at. So product name or price, those are both descriptors of a particular item that we would be looking at. All right, so again, when we talk about attributes, keep in mind that these are all going to be items that kind of describe the properties of a particular record. So again, we look at the record, I say my record is Michael Barnes, okay? What are descriptors of Michael Barnes? Michael Barnes is a professor. Michael Barnes lives in Kirksville. Michael Barnes is a banner ID of 1, 2, 3, 4, 5. At least that's what I'm going to tell you all. I'm not going to tell you my real banner ID. But yeah, all of these things are going to be descriptors, items that would be included in the database records for a particular item. Everybody in this room would have their own record and different attributes associated with them in that particular scenario. As far as the characteristics, the constructs that comprise a relational database, there's 3 of them, okay? And these are actually so easy and so straightforward. I'm guessing that you probably already know these, but I do want to make sure that we have these organized so we can think about these. So the table or relation is the primary construct. And the way to think about this, if you think about this in Access, Access actually organizes data files within tables. The same can be generally true for our tables that we look at in Excel, though that's a little bit less, it's a little bit less structured, okay? We do have kind of rectangular tables in Access. You don't have to necessarily fall to rectangular form in Excel, though I'll encourage you to do so as we're operating through records and attributes. So storage with rows and columns, much like a spreadsheet. Each table in a database represents either a class or a relationship between classes. Now, this is a really important one because we're going to be talking about classes. We can set up artificial constructs, or they can be conceptual structures or construed otherwise, that basically represent combinations of information across tables. We'll talk about why that's the case here in just a bit when we wrap up here. But columns are tables that are called fields that represent the attributes or characteristics in the class or relationship. So those columns in the spreadsheet, okay, all of those things that are descriptors, those are the attributes. You will hear me use the term field as well. I will interchangeably use the term fields and columns frequently because they mean exactly the same thing. Fields and columns are identical. And the rows are tables that are called records, which I use frequently. You can also use the word tuple, which, by the way, I never use. I don't never picked up that one. But they represent all instances of specific data values that are associated. So it's an individual record, okay, is one instance of a data value. So again, record for me is Michael Barnes, Kirksville, Missouri, professor, Truman State, stuff like that, okay? That's how you would think about a row, whereas the columns would be each of those descriptors that we would actually think about. Name, position, location, workplace, whatever you want to call it. So these are kind of the examples of how we'd see these. This is an example from an Access database, but you can notice this looks very similar to an Excel. We could replicate these in Excel. The table itself is represented the tabs that we would actually leave there. So this is the relation. So remember, these represent the entities that we would talk about, the entities that we see within those UML diagrams. The column is a field, okay? So each of the columns represent the fields, which are the attributes of the individual records. And the records themselves are each instance within the entity. Now let's go ahead and make sure that we have some details down. We're going to talk about primary keys and foreign keys in a lot more depth. I am going to caution you that I think this is really, really important. I always ask questions about this on the exam. So when we start going over the next 3 slides, you should probably put a star next to this and say, I should know this really, really well. Not to say I won't ask questions about other stuff, but I will tell you this is 100% to be on the exam. So the relational keys or relations in a database interact via keys, and there's 2 categories of keys that we've already talked about. We talked about primary key, which is a unique identifier for a specific row in a table. All right. What do we say our primary key is for everybody in this room? Our names. Okay, right. It's our no. It's banner ID. Okay, banner ID. We talked about this already. So people have People can have the same name, but we all have a unique banner ID. Even I have a banner ID because I have to operate in the system. So we all have a unique banner ID. All right. So it uniquely identifies a particular item within the table. Then we have foreign keys, which is a little bit more distinct. This is attributes in one table that act as a primary key in another table. These are what provide a logical relationship or link between two tables. Now, foreign keys, I would argue, are probably more important conceptually than primary keys. You can make an argument that says, well, they're not actually that as critical as primary keys because you can't have a foreign key with without a primary key. And to that, I will respond, touche. All right, but the idea of a foreign key is what holds entire relational databases together. If we do not have the ability to link tables, we don't have a relational database. So the foreign key conceptually is probably more important because we have to be able to identify those within other tables, identify keys within other tables to match them to the original tables. So an example of this is kind of an example. So we have artists here with recordings. So it'll be a good one. I did Sabrina Carpenter last year, so we'll do Chapel Roan. Okay, so everybody's like, so Dr. Barnes actually knows the names. I'm not that. I actually heard about the VMAs. Apparently, Lady Gaga won Artist of the Year. She did that like 17 years ago too. So yeah. Anyway, artist ID, Chapel Roan, and then you can talk about what her artist ID is and the recordings here. So she's got a record. And you could say, I don't know the name of her record, but there was like the songs that had Hot to Go and Pink Pony Club that she had on there. There's on the album. Okay. So whatever the recording is, whatever that would be, it would actually have the name of the recording or the ID of that album. And then there would be an artist ID. So Chapel Roan would be something like 5467. And that would be our artist ID that she would actually have a unique identifier. If we were to record this in a relational database, basically what's happening here is that, the album ID here, and not necessarily the album name, but whatever the album identifier is, would be able to be matched to the artist via this artist ID that's recorded here. So a recording has an artist that's associated with it. So I'm trying to think. I'm going to try to think of a name. I'm going to go way, way back because I don't know any modern names. So modern ones. So all right. So we'll talk about my favorite musical, Hamilton. Does anybody ever listen to Hamilton? Okay. Yeah. Good times. All right. So Hamilton original cast recording. Okay, so that's the name of the album and who is the artist associated with? We'll say Lin-Manuel Miranda. Okay, so what are the attributes of Lin-Manuel Miranda? That would be his artist ID. He would have his name in there and then whatever his identifier is and all those characteristics. We can match the recording to the artist via having this artist ID here, and then everything that's in the artist table can actually be now drawn over here to the recordings identifier because we have a way to match that information. So that's really, really important and really, really critical. And that requires that we have both a primary key within the main table and a foreign key that we can use to match. Now, in order for this to work, in order for a relational database to work, we have a few rules we have to follow. These are where things get really important. If we break the rules, then everything breaks down. If we lose our relational databases, society as a whole comes to a stop, everything collapses, and then we go back to being cavemen. Okay, so yeah, we've got to make sure we follow these rules. Our lives as we know it depend on them. You may think that, well, I'm worried more about health and safety and making sure that we save the environment and that our society lives. I'm going to tell you, let's put relational databases right up there, making sure we retain integrity of relational databases because those are important as well. Okay, so two rules that we need to note they're going to be asked about are going to be the entity integrity rule and the referential integrity rule. The integrity rule we're familiar with. We talked about that last Wednesday. So primary keys must have data values. Whenever we have a primary key in a table, there has to be a data value input there. So an example would be is if we have a table for everybody in this room, for all the individuals in this room, okay? Every single one of us has to have a banner ID listed there because otherwise we can't have an identifier for that. Because remember, that's our unique identifier. Every single person should have a banner ID. If I'm missing a banner ID, then that's an invalid row. That's an invalid record. Okay. So primary key have to have data values. Now, foreign keys either must be null or must one of the data values that already exists in the corresponding table. So remember, if we're talking about say, for example, I've got another table that's going to be who handed an assignment, okay? Who handed an assignment, and I can actually match that according to what would be the original classroom identifier, the classroom list of the banner ID. Now, we know, logically speaking, that most people in that table are going to have records in the original table. They're going to have records from the primary keys from the original table. Presumably everybody, okay? Presumably everybody. But what this is telling us, the referential integrity rule, is that a foreign key can either be a valid primary key from another table, or it can be blank. It can be null. Does that make sense to everyone? It shouldn't, okay? Everybody should be kind of like, wait a minute. How can it be null, Dr. Barnes? You just told me it has a primary key, and be able to match is really important. It is. But why can it be null? Why can it be null? Well, let's think about a very simple example. All right, let's assume that we have a business that operates both online and in person. And that's many businesses that operate online. More importantly, when they do in-person transactions, they do cash transactions. So is it possible that you can have somebody that comes up and performs a transaction with your business, and you have no record of that person's existence? Somebody comes up and says, I want to buy something, and hands you cash. You give them their good, and you never get their name, you never get an identifier, you never get any kind of transaction history. So is there a record of that transaction? Absolutely. Is there a record of the individual who was involved with the transaction? No, you have no identifier there. So that's a null record. That's an easy example of how a null record could exist. So null records are certainly possible with foreign keys. They're not common, but they're certainly possible, particularly if you have different business methods. If you had an online transaction, then you require somebody who's online, they probably have to have a login identifier. Like whenever I go buy at Amazon, I've got to sign in with my email address, which, by the way, is a very old email address that I will never tell you all because you'd make fun of me for it. Okay. But I have to sign with my email address, and I have to make sure that I'm identified as the person it is. And whenever the transaction occurs, they've got my unique identifier associated with that transaction. So that would be an example of that. Now, each attribute must have a unique name, okay? So each attribute, so when we have columns within a table, we've got to have a unique identifier for each column, okay? And presumably one that's a descriptor of whatever that attribute is. That's really important, okay? Each attribute must have a value, attribute of the same type. Each value of attribute must have the same type. So say, for example, I've got a row that's going to say transaction amount, okay? One transaction amount says $1,000. Another transaction amount says $2,000. Third transaction says ABC. Does everybody see a problem with that? ABC is not a numeric input. If you do that in an Excel file, it will probably flag that and say, this is probably doesn't look like everything else. It's weird. If you try to do this in an actual database system, it will say you can't put that in there. It's a numeric identifier only. So they have to all be at the same value in order to be, or same value type in order to be relevant. Each attribute or record can only have a single value. This is an interesting one. So we have a single value. So basically, you've got a field and a particular field record. Can you input multiple items to that same field record? This is going to say absolutely not. Okay, absolutely not. Which is really important, by the way. We're going to talk about why here in just a second, but I want to finish this table before we do. All right. Non-key attributes should have described the characteristics of the relationship identified by the primary key. So basically, if it's a non-key attribute within a table, it should be an attribute that's a descriptor. There's no reason to include something in a table that's not a descriptor. All of our attributes should be descriptors of the primary key. Now, I want to talk about this one right here. Each attribute of the record can only have a single value. Why is this important? And the answer is it answers our problem from homework last week. Remember 16 and 19? And I said, hey, does everybody know the answer to this? And then you said, yes. And I said, it's probably not the answer you thought it was. And then I explained I would come back to it. Guess what? We're coming back to it right now. So let's go ahead and take a look back at our homework assignment that we were talking about, okay? So, oops, not this one. So remember here, I said, in this table where we had buy-sell transactions and stocks, okay, primary key of stocks is a foreign key in buy-sell transactions. So we could say you get a stocks as a foreign key here, but you can't have buy-sell transactions as a foreign key here. And I said it had to do with the multiplicities that were listed here. Let's define why that's the case, okay? So here I've got an example of a buy-sell transactions table along with a broker's table, which is exactly the same situation. When I got my transaction, I've got the individual transactions listed out. And because of the way that it was defined, you can only buy one stock for each individual transaction. That was the way the table defined it. One stock for each transaction. So each transaction has one stock and only one stock. So the stock is listed out here, and I could actually list out stock ID because of that. So A1 and alphabet. So you'll notice this is our primary key. Can everybody agree that this is our primary key? Okay. This is our foreign key, because we only have one item that can be listed here, a maximum of one item, okay? So that's the case. We got that listed out here. Now let's go down to the stocks table. Stock ID A1 is alphabet. Can I list the transaction IDs out here? Well, let's look at the number of times alphabet is used. It's used here. It's used in this transaction here. It's used in this transaction here. It's used 3 different times. Why don't I just put 3 transaction IDs right here? Is there a reason I can't do that? Absolutely, there's a reason. I said that can only have a single value. That was what we just talked about in this slide. Okay, can only have a single value. In other words, if it has a maximum of many in the multiplicity, you cannot use it as a primary key because it violates the rule of having a single value. Okay, so that's why we can't list out transaction ID here. Same holds true for the brokers table. Now, just as a little point of context, this comes up because in the past I've said it has to be a one-to-one relationship. Would the same rule hold true if this was a 0-to-1 relationship? Let's go ahead and let's do a fun example, okay? I created a little customers icon down here. So let's go ahead and say that I'm going to add another table on here. Add customers, and customers have a similar relationship, but customers could have 0-1 relationship. You could have a customer with 0 buy-sell transactions, or could have 0 buy-sell because it doesn't get recorded, or 1 transaction. So just assume with the menu got a 0-1 multiplicity. So does this hold up here? So I'm gonna have to make this smaller to fit everything in. Okay. Actually, I could just use freeze panes. I teach you all freeze panes, and then I don't actually use it. How terrible am I? Here we go. There we go. All right. So we have customer ID. All right. We have the customer names here. So transactions are all listed out here. And then there's one transaction that looks like the broker did not actually get a name here. Maybe apparently somebody bought by cash, which is weird for a bilateral transaction. I get that, but we'll assume that's the case. Their username, which is fine, okay, because it tells us that we don't have to have a customer name for the transaction. So are we still recording this as a foreign key? Is this a valid series of foreign keys? Yes, because the referential integrity rule tells us that it has to either be a primary key from another table, which it is here. Here's our primary key for the customers table, or it has to be blank. It could be null, all right? So if we have a 0-1, that means that we can have a value or we can have a null value. If we have a 1-to-1, by the way, this 1-to-1, this will always have to have a value, okay? Because we always have to have a transaction there. Now, can we record this here? Can we record this down here, the transaction ID? Answer is no. Again, the same reason. We've got this customer. Customers have multiple transactions. So you know Kathy Otero up here has got 2 transactions listed up here. I can't list 2 transactions in a single cell. That's not a valid input for a database system. So I cannot use this transaction ID up here. I cannot use the transaction ID as a foreign key down here because it has a more than a maximum of 1 in the relationship. This is really confusing, by the way, and it really takes some time to grasp, but it's really important to grasp because this is really important for database integrity. So if you don't grasp it, rewatch the video. If you do grasp it, give yourself a pat on the back, okay? If you're kind of like, I kind of grasp it, reinforce it, okay? Because you want to know that for the exam. All right, moving on. Let's go ahead and wrap this up. We're going to talk a little bit about how this would be set up, and I'm going to do this really quickly. So this is an in-class discussion example. This is actually in your book. If you go, where's that? If you go to problem background for problems 10 through 13, there's a lot of tables listed here. We're not actually going to do problems 10 through 14, but I did want to use this as a template for discussion. I do have this table on Brightspace if you want to download it for reference. And you'll notice it doesn't exactly match what's in the slide. This slide's in the old edition of the book. And these tables actually refer to the dates that are new information. There's like a deviation in dates. Ignore the stuff on the slides. It's just kind of like saying that this is kind of what we're going to be talking about. But you'll notice that we've got some series of tables here. We've got author and book, and we've got customer and sales line item. Now, we're going to talk about some disparities here. So first of all, is it possible that you can have an author that wrote more than 1 book? Okay, so there's a relationship between an author and a book, and you could have somebody who wrote more than 1 book. In fact, it says that. The author's book is that we've got an author here that wrote 2 different books. And so we got that listed here. Now, is it also possible that you can have a book with more than 1 author? Yes, that happens frequently in academic textbooks, by the way. So what is the issue here is that we've got 2 tables that we can't create foreign keys with. We can't create a foreign key with because both of them have something to many relationships. What is the solution to this problem? The answer is we have to create a separate table that actually identifies these relationships. And you will notice here, author ID, we've got the same authors listed more than one time for several of these. And in book ID, we've got the same books listed multiple times, or same book IDs listed multiple times, because a book can have multiple authors. So the question would be, what happens when we can't create a single foreign key from the author ID or from the primary keys in these tables because they don't have the proper parameters? The answer is we create a new table with a combination of both the primary keys to create a combination foreign key. So this is going to be a foreign key that we would use. We'd say A1, B2 would be a combination of fields for a foreign key. And that goes back to our definition from last week. We talked about how a foreign key could be a combination of fields, or primary key / foreign key could be. Now we have our customer here. Now a customer can be involved in only one sales transaction, which makes things a little bit easier. So real quick before we wrap up, because I'm running out of time, we do also have a table called sales line item. I really don't like the inclusion of this table because should it be sales line item or should it be sales transaction? I would want to look at sales transaction. Why did they include sales line item? This is a table that's created from the sales transaction. And the reason why is because a customer can buy more than one book. And that's what happens here is you see the same customers buying multiple books here. So I actually created this table. I created something fictitious. This is not something that's actually in the original data. Oops, let's see, unhide. Well, I'm trying to be clever. I've got another cell here. There we go. That's what I'm trying to find. All right, I've got another cell or row in here that I created, which is to be a transaction ID. This would be our unique identifier if we were supposed to have a table. They didn't create a sales table, but this would be our primary key. All that leading up to the idea that we can create a UML diagram from these tables if we understand these relationships. Remember, book to author is going to be a one-to-many relationship because you have to have one book to be an author. You have to have one author to have a book, but you can have many of both. Books can be involved in more than one sale, and sales can involve more than one book. A sale can have one and only one customer, but a customer can have many sales. The interesting thing about this is you'll notice here that I've got author listed over here. Why don't I have author listed as an agent over on the right? Authors usually agents in sales transactions. Like when you guys bought the textbook for this course, did Vern Richardson come to your door and shake your hand and thank you for the textbook? No, it's a piece of information about which we want detail about, but it's not otherwise involved in the entities that we've talked about. This is a conceptual structure. So that's why I include that. All right, we're out of time. We'll talk more about this on Wednesday. Homework to do then. See you then.